Okay, so we talk about circles. Now circles look like this. X squared plus y squared equal to something square. Okay, whereby the coefficient of x squared and the coefficient of y squared must be the same. Yes. Yeah, okay. And then we talk about ellipse, whereby something like that happened, right? So the coefficient different. So, but these are what I like to call closed curve. Because no matter how we draw, it's like closed, circle and all. And the feature is that it must be positive x squared and positive y squared. Now what I'm going to talk about next is if I have x squared minus y squared, it becomes a totally different beast. Okay, this beast is what we call hyperbola. Alright, now hyperbola looks like what? Well, it looks like butterfly and all. So there are two types of hyperbola that I want to pay attention to. Literally, if you take a look at this, it's not much difference from ellipse. The only difference is really the minus. That's all. Okay? So when you have plus, it's always circle or ellipse. When you have minus, it's always hyperbola. But that said and done, now you got two versions. Because x minus y is not the same as y minus x. Not like ellipse, x squared plus y squared plus x squared, no difference because it's plus. This one, now it comes with a difference, okay? So, in general, we have x squared minus y squared looks like this. Looks like a left-right version, like a butterfly if you like. Okay? We have y squared minus x squared looks like this. Looks like a top and bottom kind of version. Okay? Now, devil is in the detail. So what kind of detail are we talking about? Well, this is the slightly more detailed kind of equation that we'll talk about. The truth is, it's not that hard to understand because if you understand the ellipse, it's like similar. Because the h and k tells you the center. Right? So the center of the hyperbola is right here. It's what we call where the oblique asymptote actually crosses each other, where the center is. That's all. Now, because this is a hyperbola, it's not an ellipse, so you can't make sense out of this that say, well, this must be the horizontal radius, the vertical. No, it's not. But A and B tells you something important as well. What's the something important? It actually gives you the gradient of your oblique asymptote. So you take the B over A plus minus, actually the gradient is equal to plus minus B over A. If you like, Y over X. Okay, take the y over the x. You get the gradient, right? Y over x. So the gradient of the dotted line is the plus minus b over a. And if you know the gradient and you know that it must pass through this point, you can find the equation. Now, the irony is that when you are trying to sketch a hyperbola, the first thing you should do is to sketch out the crisscross, not the curve. Because with the crisscross, the curve comes easy. Understand what I'm talking about? Can? Alright, so how do you find the crisscross? Well, crisscross, after all, is just a line. I mean, two lines. And how do you draw lines? I mean, you need gradient and point, that's all. And point is not difficult because point, you look at the equation, you immediately know the point already. What? That's where exactly you meet. Point is easy. Gradient, you look at the equation, you also know what? Just b over a. So you got the gradient, you got the point, you can find the equation rather quickly. Once you found the equation, you can draw the crisscross, and then you start putting in the wings for the butterfly. That's all. Now the details about what's a y-intercept, x-intercept, and all these things are actually super easy. Make y 0, find x, make y x 0, find y. That's all. Now the challenge that I have when I was a student like you is actually after I draw the crisscross, I don't know how the hyperbola look like. Whether is it like that or whether is it top and bottom. That is my problem, or rather that was my problem. Okay? So how do you overcome this problem? Well, it turns out there are a couple of ways. The fastest way is to go to your GC. Go to your GC and you go to the conics function in your apps. Sorry, it looks like that because that's the only version I have that looks like that. Okay, so you go to conics. Circle is lame. I hope nobody use this function, please. Ellipse is even more lame. All right, nobody use this function also. All right. Hyperbola, yes, that's what we're going to use. Okay, so we go to our GC, we use hyperbola, and this is the screen that saved me. That's all. I don't need to use anything else because I look at this, I tell myself, oh, x squared minus y squared, oh, it's the left and right version. Y squared minus x squared, oh, that's the up and down version. Okay, that's good. That's all I need to know. Done. That's what I meant by using a GC. Help me memorize which side. Now, if you don't have a GC on hand, you can still draw this because all you need to do is to find the intersection yourself. I mean, you can find this point, you can find this point, you can find this point, then you just think about it. how to connect the points. I mean, you can't connect the points by drawing this. This is the only way out. So far, so good. Now, but I also don't want to make it sound like your GC is completely useless. Okay, your GC does have some usefulness in it. But I want you to understand that a hyperbola is not very scary. You can draw it without a GC altogether. And you can draw it in under 2 minutes. It's quite fast and it's quite easy. Okay, really just draw the crisscross, figure out the left and right shape. If you don't have a GC to figure out, then you draw and find the intersection point yourself. And then you connect the dots, that's all. It's either left, right, or up and down, that's all. It's not hard. Maybe I should show you one example, right? To convince you that you can do it without a GC at all. These are the steps. Okay, but anyway, let's talk about this. This is a bit too easy. Hold on. Let me see if I've got another example. Maybe this one. Okay, cool. All right, so let me use this as an example to show you how things can be done, or rather, how I want you to conquer it, all right, so that it doesn't appear scary at all. All right, so let's take a look at this. How do I sketch this without my GC? Okay, first of all, identify this is a minus. Okay, so it cannot be a circle, it cannot be an ellipse. All right, it must be a hyperbola. What kind? I also don't know, but never mind that. You need to make sure this is 1. Okay, because it's always like x minus h is k, y minus k square, right? There's no 2y here, all right? So you got to, first of all, get rid of that. How do I get rid of that? Well, I think there's a small problem. Factorize out the 2, you're going to get 4. So far, so good. Not that hard, right? Okay, cool. Now, same thing as your ellipse, the right-hand side must be 1. So you have no choice but to divide throughout by 4. I can start drawing. Okay, how do I start drawing? Well, first of all, I need to know the center, so let's try. The center will be at -1, 2. So where's the -1, 2? -1, 2 is right here. That's where my crisscross will meet. Next, I need my gradient so that I can find the crisscross equation, right? So this is over 1. So the gradient of the oblique asymptote is plus minus 1 over 2. Are we good? Okay, 1 over 2. So that's the gradient, that's the point. Maybe I should label. I can find the equation, right? So the equation is y minus 2 is equal to half times x plus 1. So y is equal to half x plus half plus 2, so that's 2.5. That's my first dotted line I'm supposed to draw. All right, I have another one. Y minus 2 is equal to minus half x plus 1. So y is equal to minus half x minus half plus 2, so that's 3 over 2. That's my second dotted line. They all meet there. All I need to pay attention to is the y-intercept, really. Agree? So you go to your y-intercept and you start drawing dotted line. One looks like this. Okay, very ugly, I know, but never mind. The essence is the important thing, okay? So there you go. That becomes my oblique asymptote. This is 5 over 2. This is 3 over 2. Okay, label the equation, please. This is y equals to x over 2 plus 5 over 2, whatever. This is y equals to minus x over 2 plus 3 over 2. Now, I need to add in the wings. It's either the left, right, or the up and down version, right? Okay, so let's say I can't remember, Mr. Ang, because there are two versions, too confusing for me. X squared minus y squared, I can't remember it's left and right or up or down. How? Not the end of the world. All you need to do is think. If I let y be 0, just look here. If I let y be 0, what will happen? Well, can find x or not? Let's try to find x. So let's try. Y be 0, you're going to get 4 here. Correct? Minus 0 minus 2 is minus 2 squared is 4. So it's minus 4, bring over. You're going to get 4, right? So 5, 4, 1 plus 4, that's 5. 5 times 4 is 20. So it's square root 20, and then you plus minus square root 20 minus 1. Okay, so you have numbers that are plus minus. So your x values will be somewhere here, somewhere here. So that tells me good enough already, because I know that it must be left, right. It cannot be up and down, otherwise how to cut here? Agree? Another way you can try to sort this out is to let x be 0, find the y-intercept, because you can better check the y-intercept, because I'm not too sure whether is it like that or whether is it like that. Agree? So you may just draw it wrongly, you know. So you have to find the y-intercept because I'm without GC at all. So how do I find the y-intercept? Let x be 0, right? So where x is 0, you're going to get 1/4 here. Correct? So 1/4 bring across is going to be positive. Here is negative, here is positive, you cannot square root. So there's no y-intercept. You follow? Can visualize now. Come on, try. 0 plus 1 is 1, right? 1 squared over 4 is 1/4, right? This 1/4 bring across. 1 minus 1/4 is 3/4, correct? Negative equal to 3/4. You cannot square root what? There's no y-intercept. Okay, so it should look like this. Now, but in your sketch, pay attention. You do need to give them this information called the vertex, which is the two parts that are closest to each other. This is part of the job. It's like whenever you draw a curve, you have to give turning points, right? There you go. That's the one. How do you find that? Well, please don't go and differentiate. Don't waste time. Okay, of course, one way is go and differentiate, find gradient with infinity, whatever. This is lame. Easiest is this. Because there must be a vertex, it must be on level with the intersection point, the center. Correct? So you know that the center is y equal to 2 what? Correct? So confirm y equal to 2, right? All you need to do is to substitute in y equal to 2. And magic happens because when y equal to 2, you're going to get 0. Okay, when this is 0, you're going to get x plus 1 squared over 4 equals to 1. So x plus 1 is equal to plus minus 2. X is going to be equal to 2 minus 1, which is 2 minus 1 is 1. And then minus 3. So this point is minus 3. This point is 1. You're done. Are we clear? Hyperbola is not scary. It is scary because you didn't know how to handle it, that's all. But let me show you something else, which is you probably find it a little bit more cool. Okay, but what I want you to understand is that you could have done it this way, completely without your GCE at all. Are we cool? Can? And this is why I want you to be able to say that, hey, I can do that. Okay? Because that makes you feel like, I don't know, it should make you feel a bit good, right? A bit good about hyperbola. But my point is this, because we always have GC. Not that this is completely useless. There's some use in it. Okay? Let me show you. All right? This is this version, right? X squared minus y squared. So you choose the correct version, please. Put it in. You need to fill in all the blanks, unfortunately. So that's what we still have to do. Okay? So the one below the x is 2. Okay? The one below the y is 1. Okay? The h is the x coordinate. And that's minus 1, okay, because it's minus here, so you have to be careful here. All right, and the y coordinate is 2, okay, so there you go, that's 2. Now, my point is this, after you key in all this, right, many people will do one thing, which is this, graph it. This is completely useless. Why? You already know it's left and right and all. I mean, this only tells you one thing, and that's this left and right curve. But you don't need to come to this screen to let yourself know that it's left and right? Before you even press, you already know. What else does this do? Nothing. Let me explain. You see, unlike the function where you draw graph, you can find intersection points, you can find maximum, minimum point, you can find when x equal to 2, y is your y, and so on. In this mode, completely nothing. You see, you can't do anything. You can't second function. You can't trace. You can trace lah, but that's all. Okay? So this graph thing idea is not the most useful. No, I got to get out. Okay, hold on. Let me get back in first. All right, but my point is that the graph function is not very useful because we could have drawn the graph ourselves anyway. But what is useful is this. Now pay attention. After you key in all this, right? Don't graph it, but pay attention to this button here. You see, the enter button. There's a solve in green. So what you do is you press alpha, solve. This is more valuable. Understand? This is the one that helps you draw everything that you need. This is more valuable than that graph screen, right? That graph screen useless. Get the point? This is more useful. It tells you the vertex. You can straight away come and dot these 2 points. It tells you the center. Straight away come and dot this point. It tells you the gradient. Okay, the gradient you can't really start drawing. You need to find the equation anyway. Get the idea? Okay. The only thing you don't focus on is, ironically, the focus. Okay? Out of syllabus, we don't learn. But actually, focus is the highlight of what this thing called ellipse and circle is. It's actually more important to understand focus. We should focus on the focus, but apparently not. Anyway. Okay, so focus we don't care. All right, that's another thing altogether. We don't care. But this is the useful screen that I want to show you, and I want to tell you that if you use a GCE, this is only for this purpose. Okay, because it makes you faster a bit. But a lot of the drawing information you actually already know. Are we all clear? Okay? So hyperbola is not that scary. Okay, it's the question that comes after that that's scary. They ask you to draw another curve, then they ask you for the 4 intersection, 3 intersection, how big, how small. That kind of question is more scary. Are we all clear first? Okay? Okay, cool.